Today's webinar entitled Harnessing the Power of Apache Hadoop Series, How to Manage Your Apache Hadoop Lifecycle. My name is John Zuanich, Marketing Specialist at Cloudera, and I'll be your host for today's webinar. I'd like to start by covering a few housekeeping items. First, all lines will be on mute throughout the webinar. If you have a question, you may ask it via the questions panel located on your webinar console. Slides from today's webinar will be made available to all attendees after the event, along with a recording of the session. We will leave 15 minutes for questions after the presentation. However, you may submit a question at any time during the webinar. The webinar will conclude at the end of the hour. I now introduce Charles Zedlewski, VP Product at Cloudera, presenting Harnessing the Power of Apache Hadoop Series, How to Manage Your Apache Hadoop Lifecycle.
Thanks, John. One more item. Our plan is for this talk to take about 40 minutes, after which point we'll do some questions and also give some updates about future events that we'll be sponsoring here at Cloudera. This presentation is focused on sharing some of the lessons that we've learned over the past several years, helping organizations of various sizes run the Apache Hadoop system in production. The good news and bad news for Hadoop today for most organizations is that Hadoop has become a very valid tool to solve a wide variety of business problems. The bad news is for those organizations that are adopting Hadoop is that there is now very substantial tangible business value being attached to the operation of Hadoop systems on a daily basis. As a result, the expectations for how the system operates in production have changed. And based on the financial impact of use cases like content optimization or loyalty programs or fraud analysis or trade reconciliation, it's more and more important that people take a proactive stance to managing the life cycle of their Hadoop systems. If you look at what most organizations are looking to achieve with running their Hadoop systems in production, it's really not that dissimilar from running any other kind of platform technology in production. So they're looking to be able to discover issues with their Hadoop systems before they start to impact their business and operational goals. They're looking to be able to diagnose the root cause of issues that they've discovered. They're looking to be able to quickly make changes, take action to based on what they've learned, and do it in a way where they're not going to wind up compounding the problem. And they're also looking to have some better insight into the running of the system over a longer period of time. They're looking to be able to make more intelligent decisions, smarter policies that can optimize the quality of service and the availability of the system for the long haul. So I think if you look at those types of needs, they really wouldn't be that different if you were talking about managing a cluster of Oracle databases or a series of operating systems or server applications. So what's different? Why have a discussion about managing your Hadoop lifecycle? I think the point is that while the needs for Hadoop as a system are very familiar, there are some unique challenges presented by Hadoop. Hadoop is a very different kind of platform technology compared to the ones that preceded it. And there are parts of Hadoop which, if you are anticipating running Hadoop in production, there are aspects of the system which are actually better than what you've experienced in the past. So Hadoop is very fault tolerant. Hadoop is extremely good at handling a lot of different failure situations: task failures, job failures, node failures, hardware failures. A lot of that kind of handling has been built into the system. So some of the things that you might have needed to do to manage the life cycle of your, let's say, application servers, for example, or your databases, you actually don't have to worry about as much when you're managing the lifecycle of a Hadoop system. So in some respects, you come out ahead. Similarly, one of the strengths of Hadoop is its scalability, right? So Hadoop can scale pretty well from a few terabytes under management up to many, many petabytes under management. And it scales with much less stress and with much greater ease than a lot of other systems that you might have worked with in the past. So another big benefit that you get from Hadoop is you know that you can start small and scale substantially without having to completely redo your system. And that's actually very different than a lot of other platform technologies. A lot of platform technologies, if you go from 5 terabytes under management to 5 petabytes under management, you might as well design a completely different system. And Hadoop will actually more or less be the same design from 5 terabytes to 5 petabytes. Another nice perk from Hadoop in terms of its life cycle is that Hadoop is already used on a pretty widespread basis today. So you know that you're not really working with experimental technology. You don't have to be concerned about, like, well, you know, how many other people have identified bugs in the system before. So a lot of the failure cases have been seen before. So that's another nice advantage as compared to working on technology that has a much smaller base of users, right? So you know that a lot of these things have been seen before, and there's a pool of expertise that you can draw on. At the same time, there are other things about Hadoop that are special and different, which make it harder to manage compared to other platform technologies. The number one thing by far is that Hadoop is a distributed system, and the way that you can discover and diagnose issues in a distributed system is just much more challenging than what you needed to do if you were trying to discover and diagnose issues on a system that worked on a limited number of servers. Hadoop is also very verbose, so it has multiple metric frameworks, lots of things that are spitting out logs. There's just a sea of data that Hadoop generates, and extracting the signal from the noise can oftentimes be a challenge. If you contrast this with other platform technologies, and the data they generate is a little better curated than what you find in the Hadoop stack today. And I said stack, that really brings me to the next point, which is that Hadoop is multi-layered. There's multiple different services running on multiple servers. So there's multiple layers horizontally of additional servers and multiple layers vertically of additional services. So it's very common to see Hadoop systems that have where one server might be running both task trackers and region servers and data nodes and client applications and agents and these things have interdependencies among one another. So the number of different interconnections in the Hadoop system are relatively substantial, and those dependencies are going to create their own class of lifecycle challenges. The last thing that represents something of a challenge is that because Hadoop is so widespread, the demand for Hadoop skills is quite high, and it's still a relatively young technology, so it's not like finding hundreds of thousands of DBAs already on the market. From Cloudera's experience, many organizations that we encounter, when they're first using Hadoop, they're essentially using it in a proof of concept type of fashion. And the working model that you see there, you can think of it something like a hunter-gatherer state, where essentially there's one project or use case that's been identified for this Hadoop system, and there's a project team which has been assigned to care for it, and everyone's doing the same job. So whether it's writing MapReduce jobs or authoring Hive queries or configuring the system or building the system or changing the code or building the code, all of this is managed by the same class of people. And everyone's still pretty impressed that Hadoop actually works, but that lack of specialization and the fact that all of these different changes are fused together makes for a relatively unsustainable model long term. So this is a perfectly fine model for POC stage. It's an unrealistic model, most likely to manage Hadoop's operational lifecycle. And people are typically finding that, okay, that first use case is starting to work, it's starting to bear fruit. I want to start thinking about how I'm going to now run the system in production and run it in a more disciplined manner. So first order of business, as you think about exiting that POC stage and moving into more of a production life cycle is, what are your goals for the system? What the goals you set for the system are going to drive the operational procedures that you put in place to manage its life cycle. I think it's first important to start with what are the business outcomes that this system is supposed to deliver. So what's the objective of the use case? And what are the business metrics that we're going to look at to know whether or not this use case is continuing to deliver value as we operationalize the system. That's going to lead to what the operational goals are that you want to set for the system. So, Hadoop today gets used for lots of different use cases. Sometimes multi-tenant use cases, ad hoc analytic use cases where you've got lots of users. Sometimes for data processing use cases where you have limited users and it's very locked down. Sometimes for real-time system purposes. And based on what kind of use case you have and based on your business goals, you're going to set different operational goals. Because striving for a given level of flexibility is different than striving for a given level of performance or utilization or availability or quality of service. So not all of these things are mutually exclusive, but in general you need to set goals based on a given set of business priorities which drive a certain set of operational priorities. I think the next thing that we tend to see is that people who are exiting the proof of concept phase and starting to think about managing their Hadoop lifecycle are going to revisit some system design decisions. So perhaps in the POC phase you're running on a bunch of EC2 instances. Or perhaps in the POC phase you cobbled together some servers that you had readily available that you knew weren't maybe the best things for Hadoop, but you knew they were going to get you through that first use case. Now that you're thinking about productionizing the system and you know that there's business value in Hadoop supporting this use case, you're probably going to wind up revisiting what kind of system you want to live with for the long term. I think that the macro point that I'd want to impart at this stage is stick to the basics. There are kind of a canned set of first principles that you want to start with when thinking about system design for Hadoop. And the goal is to not get creative. Hadoop was designed to work on commodity hardware and to manage failures at the software level. That's central to the design of the Hadoop, to every layer in the Hadoop stack. And so when you think about designing the system that you're going to want to productionize, you should really think about sticking to those first principles. That means on the server front, think about prioritizing flexibility over bells and whistles. Your ability to adapt and change the system as your use cases change, as your usage grows, is far more important than optimizing the system for a very narrow use case today. So questions you should be asking yourself are, how easy will it be for you to expand your cluster based on the decisions you're going to make today? How easy will it be for you to change the number of cores or the number of spindles you have in your cluster? Because it's very difficult to forecast right out of the gate. It's very difficult to forecast how much storage you're going to need and how much processing power you're going to need or how much memory you're going to need. The great thing about Hadoop is that it works fairly well with heterogeneous hardware. So it just means that you need to think smartly about picking hardware partners that can adapt and grow and evolve with your needs. And you should think about every time you're tempted by that exotic CPU, that exotic card or drive or power supply, those out of the ordinary things. So how much is that going to cost me? How many different vendors support this if I want to change over time? And what does this add to the per server cost? And what if I saved all the money and just added a few more servers to the rack? That's oftentimes the better decision as opposed to reaching for the exotic out of the gate. So meta point, stick to the basics, and prioritize flexibility, ability to adapt over optimization out of the gate. A couple other principles. Hadoop as a system manages its own storage, and so consequently it needs to know where its hard drives are. So the default setup for Hadoop is a bunch of JBOD drives. That's very different than the normal practice for lots of other applications in the data center that are more often use virtualization or RAID or external service. All of those things today will represent a pretty meaningful impairment to the quality of the operation of the Hadoop system. So again, stick to the basics, stick to the recommended configuration, allow Hadoop to work to manage its own hard drives. Lastly, network. So Hadoop's a distributed system, and that means that network design is important also. Again, this is a situation where quality and flexibility and ability to adapt is more important than exotic or bells and whistles. Again, Hadoop is designed to work with commodity hardware, so on a per-server basis, 10G is usually unnecessary. The other thing I would say is that if you're going to be starting with Hadoop at anywhere between 5 to 100 nodes under management, the network design is fairly simple. But you should be thinking about what happens if you grow to several hundred nodes to thousands of nodes under management. If you do, the network topology starts to look fairly different. So you should think about what your plan is to grow and how easy it's going to be to evolve from one network design to the next. Oh, maybe it doesn't go without saying, but Hadoop is not designed to work over a shared network. So that's another thing which might come as a surprise to some people who are thinking about operationalizing Hadoop. So where we want to get to as Hadoop moves into production, we want to manage it like a full life cycle. We want to think less about hunter-gatherer and more about tribe. We want to put someone in charge of the usage of Hadoop. We want a chief. And that chief is going to be someone who makes sure there's enough resources for everyone and make sure that the system is available for everybody to use. The first thing I would consider, I would urge you to consider is whoever your chief is going to be, and a chief, in my experience, tends to be someone with a role like Hadoop Ops or Hadoop Administration, is you should really be planning on training or building up your chief more than you should hiring your chief. This is just a chart most recently of the trends for job listings for people with Hadoop skills. The likelihood today that you're going to be able to find somebody with multiple years of Hadoop operations experience just on the street who happens to be looking for a job is really very low. The growth and usage of this technology is just happening at a pretty rapid clip, and it's just not a realistic strategy to assume to put out a job spec saying must have multiple years of Hadoop operations experience. And that's okay. Because it's possible you can train your chief. We have seen, at Cloudera, we've seen many good success stories with people who have profiles as Unix sysadmins or DBAs that with training and some experience and some mentoring turn into excellent Hadoop operations people. And you're far more likely to find a bright Unix sysadmin or a bright DBA that's wanting to learn Hadoop than you are to find someone who's already got multiple years of Hadoop experience. So consider building, not buying your Hadoop operations team. The next thing would be to say is you want to empower your chief. So I think that in order to manage Hadoop effectively, to manage the Hadoop lifecycle, the people that run the system are going to need to be able to exercise their judgment across a number of different parts of the system. They're going to need to have a point of view about sensibly selecting the hardware that's in the system. They're going to want to have visibility into what users have access to the system, what jobs and activities are running, what hardware is being used, what the operating system's doing, what the services are doing. They're going to want to be able to make changes to services, patch levels, configurations, and more. When you think about other applications that you run in your data center today, it's oftentimes the case that the responsibility for some of these things is doled out to different departments. Maybe you have a server team and they own all the changes to the operating system and they have all the access to patch everything below the application, and then you have a different team that manages the application. You keep these two things segregated. That probably makes perfectly good sense for a whole host of different applications that you're running in your organization, it's probably a little more challenging if you're going to be trying to manage your Hadoop lifecycle. You're going to need to give the Hadoop operations team a little more control and discretion around how the entire system runs. Hadoop's a relatively low-level system, and a lot of the things you need to do to manage your Hadoop lifecycle require that you have visibility into lower-level aspects of the hardware stack. One way of thinking about this is think about Hadoop as sort of a virtual appliance, right? So today, most organizations consume appliances, and people have very little visibility into what operating system those appliances are running, what JVM they're running, how often, what kind of hardware is being run inside those appliances. All of that's opaque, and that's considered acceptable for an appliance. And so Hadoop, you can kind of think of the same way, is that those servers that you're using for your Hadoop system, they're essentially dedicated to this purpose. They're not going to serve other applications. They're pretty much just servicing the Hadoop cluster. So think of Hadoop kind of like a virtual appliance. It's downloadable software. You're not wheeling in a cabinet from some proprietary vendor, which is a good thing. But you should really think of it as a bit of a closed system. It's not like you're going to have lots of other programs running in the same servers that are nodes in your Hadoop cluster. And allow your Hadoop ops team to make these intelligent decisions about how these Hadoop servers are run. Okay, so let's get into some of the operational aspects of the Hadoop lifecycle. Discovery. I want to be able to proactively understand things that might jeopardize my operational goals for my Hadoop system. Remember, we set goals for ourselves in terms of maybe availability or quality of service or performance or uptime. And now we're looking to discover or anticipate threats to these operational goals before they happen. There are a wide variety of things that you want to monitor, anticipate, and alert on in order to achieve your operational goals. I think one class of things that you'll see is the need to do a variety of different forms of health checks and status checks of key nodes in your Hadoop clusters. This tends to be things like maybe your name node, your HBase master, your zookeeper quorum. You might have a gateway node. So you're going to wind up placing a much higher level of checks and verifications against these types of nodes, because Hadoop is relatively forgiving if you wind up losing a handful of slave nodes. Another class of things that you want to be able to anticipate and alert on is the completion and performance of different jobs and data pipelines in the Hadoop system. So it tends to be that the service level agreements or the operational goals that you're going to set for your Hadoop system are going to tend to get wrapped around the completion of workloads. And workloads are measured in the form of MapReduce jobs or Hive queries or pig scripts or workflows. So you're going to tend to have SLAs like the data processing pipeline must complete within 30 minutes, or the average user who submits a query to the cluster is going to need to be able to get a minimum level of resources at such and such a degree specified. So in order to be able to satisfy these SLAs, you're going to need to be able to monitor the completion and performance of the jobs and pipelines in your Hadoop system. You're also going to care about garden variety system performance and availability information. So whether or not certain nodes are swapping, whether or not you have available disk space, whether or not certain drives are dying. These are all things that you can do with any garden variety server monitor today. But these are just as important to be aware of as things that are happening up in the Hadoop stack. The other thing which is an important part of proactive monitoring alerting is log events generated by different nodes in the Hadoop system. This is again a case where you need to be mindful of what you're watching for. If you watched every single event being generated by every single node in the Hadoop stack, you would spend all of your time doing that and none of your time actually improving the Hadoop system. So it takes a bit of savvy and judgment to know which ones to watch out for, and this tends to vary on a service-by-service basis. But that's probably the other key piece in terms of the discovery process. Between log events, system performance, job and pipeline performance and completion, and node health, you probably have a pretty good ability to anticipate threats to your service level agreements before they happen. So the next part of the operational lifecycle is diagnosis. To the extent that I'm being warned about threats to the health of the system, what kind of diagnostics do I have at my disposal? Common questions people might ask: why did my job fail? Why did this node die? Why did the cluster slow down? Where did my disk space go? You know, there are all kinds of very straightforward questions that people look to ask. The principal goal of the diagnosis being, I want to find some way to prevent this from happening in the future, and I want to know what kind of corrective action I can take in the present. Diagnostics is a tricky business in Hadoop. This is where the challenge of Hadoop as a distributed system comes into play. There are 7 principal lenses that you have to do diagnostics in Hadoop, and you tend to need to do them in combination with one another. So it's really rare that one lens into the Hadoop system tells you the whole story about what's going on in the system. So the typical lenses you find are service metrics. So this could be something like you know, number of queries processed per region server, for example. System metrics. This could be, you know, something as simple as how much heap is currently being consumed. Current configurations. What's the system currently configured to do? Maybe it's misconfiguration, which is driving the failure case. Change history. So what's been done to the system most recently, and does that serve as a possible explanation for my diagnosis? Log history. So whereas you might want to warn on a certain class of log events for proactive management, you want to sort of read through a different class of log events when you're in the diagnostic phase. So the log history winds up being a really powerful form of diagnostics where you can really see a blow-by-blow of what happened to different parts of the system. You also get a pretty, you also need to have some visibility into the activities, jobs, and tasks of the system. That's another piece of the puzzle. And the last piece of the puzzle is some form of tracing or profiling, right? So that's yet another kind of form of insight. So these things used in conjunction together give you all of the information that you need to do a diagnosis. The trick is to understand and have the savvy to combine these together in the right way to get to the right diagnosis. So you've discovered some issues. You've tried to discover and anticipate issues in your Hadoop system. You've got a whole variety of different means of doing diagnostics now. Now you need to take some form of corrective action. You know, I think what's the best practice in terms of taking actions in Hadoop systems? I think the main thing is to establish practices in terms of how often you make what classes of changes. So for example, if you're making changes to Hadoop services, you know, this is nearly a daily occurrence. It's nearly a daily occurrence that you might, a task tracker might get blacklisted, a data node might get restarted, a rebalance might be performed. These are relatively mundane actions. The Hadoop system is very resilient to doing these kinds of changes, and it's relatively harmless to put these tools in the hands of the Hadoop ops team to care and feed for the cluster on a daily basis. Configuration is a different story. There's certain configuration settings which you can think of as the equivalent to tuning, right? So just like your DBA tunes the database and changes various parameters to get better performance and reliability, the same way there are lots of different parameters that you can tune in Hadoop which have the ability to eke oftentimes meaningfully better performance or meaningfully better reliability out of the same system and the same hardware. So tuning is something that for a lot of Hadoop ops teams becomes a weekly occurrence that you wind up looking at how workload profile changes, and reevaluating certain settings. At the same time, there are other classes of settings in the system which need to be much more kind of planned, tested, and staged before they're pushed to production. So when it comes to configuration, you need to draw a line in the sand between sort of the things that are tuning and the things that are more substantial system changes you're only going to evaluate once every several months, and you're going to more carefully test and stage these. Software changes are probably the thing that you'd want to make change the least frequently, and you'd want to start to set up an operational plan around how often you're going to onboard changes outside of critical fixes that you may find you need. Again, this is an example of where an appliance mentality makes sense. If you can consolidate all the software changes into a certain set of maintenance windows, you're going to have a much more beneficial result on overall uptime and overall planned uptime, as well as reducing the risk of unplanned downtime. So when you think it's time to update your MapReduce and your HDFS and your Zookeeper, you should consider also revisiting at that time, is there a new patch level for the OS that I should be considering, or is there a new JVM which looks to be pretty tested and hardened, and I should wind up bumping up to that new JVM. So consider consolidating these software changes and onboarding these at specific maintenance windows. Avoid the scripts. So we've talked about ways of discovering issues, we've talked about ways of diagnosing issues, and we've talked about different actions that you can take. The first response, what tends to happen with a lot of organizations that evolve with Hadoop systems today is they tend to be reactive in terms of fulfilling these discovery and diagnostic needs. And so they wind up building scripts. They wind up building scripts ad hoc to run checks, to do imports, to preempt or enforce some policies, to instrument one or more of the daemons, and essentially you wind up building this ever-growing sprawl of scripts that are wrapping around different servers or nodes in the Hadoop cluster. What you wind up with is what I call the man cave of scripts, right? So essentially you have this jerry-rigged web of scripts which makes sense to the person that wrote the scripts, but not to anybody else. And as you wind up expanding usage of Hadoop over time, your Hadoop ops team is going to grow. And no one's going to like the man cave except for the person that built the man cave. So, my advice would be think about this Hadoop lifecycle proactively. Try to put as much repeatable infrastructure in place up front before the web of scripts takes hold and winds up bogging down the future growth and change of your Hadoop cluster. The other part, the next phase of the Hadoop lifecycle is optimize. I think that increasingly the more sophisticated Hadoop organizations have the day-to-day lifecycle under control. They've started to understand ways to discover issues, diagnose issues, take actions. They've built up some expertise in their Hadoop operations team. And Hadoop has started to grow as usage has gone beyond that initial use case. There's 4, 5, 6 additional use cases. Hadoop is becoming a standard platform in the data center. And at that point, the level of sophistication tends to change. People start to think more in terms of long-term planning, long-term optimization. And there's a whole variety of different forms of operational reporting and policies that you want to put in place as you reach this level of maturity. One thing you tend to find as you start to optimize more is you want to plan for multi-tenancy. So multi-tenancy simply means the ability for multiple different groups and multiple different use cases to all work on the same logical Hadoop system. And this has a lot of different benefits for a typical organization. It tends to result in better performance. It means that jobs for one use case now get to run on spread out across a greater number of nodes, which will typically mean you'll get better performance. It tends to mean you're going to have a lower cost of operations. So when you have fewer clusters to upgrade, update, monitor, fix, and improve, you tend to be better off. Oftentimes, multi-tenancy means you're going to have the opportunity for new insights because more different classes of data are going to pool in the same system, which means you have the opportunity to do different kinds of analyses across those different data sets. You'll also tend to find that you're going to have greater data availability, so you're normally going to have, a larger system is going to survive node failures better than a smaller system. At the same time, as you wind up supporting multi-tenant use cases, you're going to have some additional policies that you're going to want to put in place to optimize the long-term use of the Hadoop system. One class of policies you're going to put in place are going to be related to security, authentication, and authorization. So you're typically going to want to enforce a form of strong authentication as you move to a multi-tenant model, because you don't want people inadvertently deleting one another's directories or inadvertently grabbing excess resources that they're not supposed to grab. Similarly, you're going to want to use that authentication to enforce authorization policies. You're going to want to secure certain directories. You're going to want to secure access to certain resources in the MapReduce framework. These are, and oftentimes you're even going to wind up specializing different classes of data by user pool. So it might be that your data scientists have access to a certain array of data, your analysts have access to a different array of data, your business users access to a different array of data still. Hadoop today does not have as fine-grained a permission as what you might find in a traditional database, for example, column level, table level permissions. But this is something which will be coming shortly in open source. And there'll be some talks coming up very soon about some of the things coming in the Hadoop system, and you can learn more about that then. Another part of optimization for the midterm is doing a better job of planning for usage of resources. So it's going to become increasingly important to understand the rate at which your cluster is being used so you can forecast future capacity or make changes in policies so that you can extend the life of the existing cluster. So you're going to want to understand the files and the raw bytes that are being consumed. You're going to want to know what kind of quotas are put in place that are going to prevent the cluster from being exhausted faster than you have new hardware coming online. You're going to want to understand how much task time, memory, CPU, I/O, and network is being consumed. And at this point, you've probably graduated from using one of the simpler schedulers in the Hadoop stack to one of the more sophisticated schedulers that can enforce more clever policies. You're going to want to start establishing policies to prevent bad behavior. So, for example, setting limits on errant jobs. You're going to want to better monitor and track resource utilization and do that by group so that you can periodically revisit your scheduler policies and see if there are ways where you can create a higher quality of service based on the changes that you make to your scheduler policies. So your goal is basically to deliver a cluster that lives longer and makes more people happy for the same amount of money, and to establish a set of policies which deliver a better quality of service without necessarily needing to always consume more hardware. And these are all good examples of the kinds of things you can do as you reach the optimization phase of your Hadoop lifecycle. So if I were to net this out, I would say that the operational lifecycle for Hadoop, things like discovery, diagnosis, corrective action, and optimization is very commonplace compared to other platform technologies that you've worked with in the past. But Hadoop is not a platform technology that you've worked with in the past. And the difference in Hadoop as a system is really what's going to drive the difference in how you manage the operational lifecycle for Apache Hadoop. The second big piece of advice that we'd hope you would take away from here is that the basics are not a good place to get creative in the Hadoop stack. So it's important to make relatively vanilla decisions in terms of system design and configuration to start, and reach for the exotics only after you've had multiple Hadoop use cases under your belt and it really proves to make economic sense. A third takeaway we'd hope you'd have from this presentation is that you should really think about designing a command center for your Hadoop ops team, not a man cave. And you should anticipate that over time you're going to want to plan for multi-tenancy, because you're going to wind up having more than one Hadoop use case in your organization. And this is going to wind up generating a lot of nice benefits as long as you plan your policies appropriately. So with that, I'm going to turn it back over for John for a moment, review some of the questions you have, and then we'll spend the last minutes of this webinar answering questions from the audience.
Thank you, Charles. If you found today's presentation useful and you'd like to hear more about the Apache Hadoop Lifecycle, please attend our next webinar on the future of Hadoop, presented by co-creator of Apache Hadoop, Doug Cutting, and Cloudera's chief scientist, Jeff Hammerbacher. They will be discussing some exciting new features being developed by the Apache Hadoop community. You can find this webinar in the events section of cloudera.com. Additionally, the early bird discount will end soon for Hadoop World, taking place in New York City, November 8th and 9th, so register today. Hadoop World will give you the opportunity to learn Hadoop basics, to gain proficiency in newly released projects, and to network with the world's largest gathering of Hadoop practitioners, developers, and industry luminaries. You can learn more at hadoopworld.com. So with that, let's begin our Q&A session. Charles, what's the first question you'd like to address?
So I'm just going to take these. I'm still pawing through all of these questions, but let me jump here to some of the issues I would see here. So one of the questions I was asked was, what issues need to be solved, e.g., performance, high availability of clusters, et cetera. So I think that the thing that I would say is that performance is something which gets experienced by different use cases differently. So it's very difficult in Hadoop to talk about performance in the abstract. So the nature of the work profile that you're going to put in the system is going to generate a very different set of desires for performance. And so that's one of the reasons why there really isn't an equivalent of like a TPC for Hadoop. And hopefully there's never an equivalent for TPC for Hadoop, because I think that doesn't really accurately represent how an organization wants to get performance out of their Hadoop system. I think it's much more important that you start with your existing use case, operationalize it, then measure it, understand, and then understand what the opportunities are for performance improvement, and then tune it from there. So it's very difficult to tune a cluster in the abstract. It's much easier to tune a cluster once you already have a real-world workload in the system. Related to that, there's a question, what are the bottlenecks in Hadoop, and what are the recommended hardware specifics for achieving a given level of performance? So let me add one more point to this. And by the way, Hadoop World, stay tuned for a pretty exciting talk about performance in Hadoop systems. So one of the things I would say is that a lot of the stock things you see today, like TerraSort, are fine as sort of an initial health check to see whether or not your system is running. They're not, or DFS-IO is another example. They're not especially representative of how you really experience performance in terms of quality of service for your use case. So again, it's much more important that you run a real-world workload in a real-world system and tune from there. In terms of the hardware specifics that you have at your disposal to achieve a given level of performance, it tends to be, once you wind up running your real-world workloads, you're going to understand to what extent you might be I/O limited, you might be CPU limited, you might be memory limited, and what it typically winds up meaning is you're going to want to shift the balance in your cluster in terms of how many spindles, or how much memory, or how many cores you wind up putting in a given server. The nice thing about Hadoop is that you don't have to get it right the first time. So it usually makes sense if you're starting out with your first cluster that you start with the run of the, unless you know to a moral certainty the profile of the workload that you're going to have, it makes more sense to spec a vanilla design server and then grow and evolve from there. Cloudera has had a number of blog posts up about kind of what the reference server and the reference stack hardware spec looks like. So you might want to refer to these blog posts to get some guidance in this regard. So another question that we had here was, is 10 gig on the network backplane unnecessary? Isn't latency key to data movement speed and performance? So great question. The key thing to keep in mind is that Hadoop as a system places a high priority on not having data move across the network. So there's a lot of intelligence built into the software to minimize data movement. So even though one of your Hadoop nodes might have 10 terabytes of data sitting on it, the likelihood is that in any given moment of the day, less than 1% of that data is ever moving off that server and across the network. The majority of the data is either at rest because it's not being analyzed at that moment in time, or it's being analyzed but it's never leaving the server. So that's the reason why you can get away with 10 gig on a per server basis. And if you wanted more performance out of your Hadoop system to start, you're better off saving the money on the networking and simply buying additional nodes to the cluster, which will add more memory, more CPU, more I/O, and more network to your system. I think over time, as 10 gig economics get better, it'll become eventually part of the standard spec for Hadoop clusters. It's just not something which is a priority today. Let's see here. So another question is, can you give examples of pros and cons of using a 4 by 2 terabyte disk versus 12 by 2 terabyte disk? Basically what people are asking is, do I want to buy 1 U boxes with 4 drives in them, or do I want to buy 2 U boxes with 12 drives in them? I think that what we tend to see is that to start with most use cases, a lot of people start with 4 by 2. And then what they find over time is, as they do more and more analytics in Hadoop, they find they're generating an increasing amount of derived data, and that derived data is coming to rest and staying in the Hadoop system. And as long as they're comfortable keeping that there, they're going to want more and more disk space. So it tends to be the case that an increasing number of Hadoop systems wind up being space constrained before they are compute constrained. So what that means is that for a starter use case, you're going to wind up, if you do 4 by 2, you're going to wind up having more processing power in a given amount of space in a rack. And oftentimes to start, that's appropriate. And if you're using your Hadoop for a data processing pipeline, you're probably okay staying with that kind of a spec. But if you're going to let Hadoop become a multi-tenant system, if you're going to allow more users to do more kinds of ad hoc analytics, it's highly likely that you're going to wind up wanting more disk space, and you're going to wind up moving more to a 12 by 2 type of configuration. Another question that was asked was, well, it's great that there's all these different lenses in a Hadoop. Why not throw all this data into Hadoop and analyze it there? It's a great question. Oftentimes people do. The challenge with doing this and using that as the basis for your Hadoop management is that you're going to incur a fair bit of latency and a fair bit of usability challenges if you use this on a day-to-day basis, right? So if you have a job that fails, you typically want the answer to why that is within the next few minutes, and you want a response that comes to your operator relatively quickly. So it's not realistic for an operator to have to write a MapReduce job a day after the fact to understand why, why a particular workload missed its SLA. So what you tend to find is that there's a certain class of management that happens in real time or near real time, but at the same time, it is absolutely a common practice for organizations to manage operational data stores where they do hold on to all this information for multiple weeks or months, and Hadoop is very oftentimes a great system for that purpose. There's also some great projects going on in the open source, like OpenTSDB, where people are holding on to gobs and gobs of low-level metrics for long-term analytics in HBase. Let's see. What are some other quest results? Sorry, questions that are coming up here. Let me see. There's a. I'm sorry. I'm pulling through the questions here. Okay, so here's one which is kind of, this is a little off topic, but I'll take it. I want to throw it out there anyways. There's a question which is, what is the crossover where SQL systems fall off in performance and where Hadoop shines? Well, at first I'm going to say it's hard to answer that question generically. The second thing I would say is that in our experience, it's really quite, performance is not oftentimes the reason why people are making a decision to solve a problem with a Hadoop-based system as opposed to solving it with a normal SQL database. The more often the reason why people are looking to use Hadoop is because they are looking for a level of flexibility that wasn't previously provided with alternate types of systems. So I think that Hadoop's ability to change and Hadoop's, the fact that Hadoop does not require a schema and that Hadoop can adapt quickly is far more oftentimes the reason why you might want to reach for Hadoop as an answer to your problems as opposed to some other kind of system. Another question, tactical question, with multiple spanning racks, is 1 gig to a core still okay, or you should be looking at 10 gig there? Typically what you find is that the switches wind up being 10 gig amongst one another, so the uplink, but the downlink is 1 gig. So that's why, so you do need a fair bit of bandwidth as you go between racks. But you still don't necessarily need that bandwidth as you're going between a top-of-rack switch and an individual node in the cluster. Another question here, to set up our RT for success, what kind of self-training regimen resources would you recommend? Well, obviously I have to put in a plug for Cloudera's own training. We have a multi-day administrator class that we provide. Obviously that's only a starting point. That doesn't magically turn somebody into a grizzled Hadoop veteran. I strongly recommend that you look at the blog resources that we have at Cloudera. We have a whole variety of different articles that we've written about Hadoop operations. And I think the next thing I would also recommend is to be a part of the Hadoop user community in your local area. So there are Hadoop user groups in almost every major city. At Cloudera, we try to sponsor as many of these as possible. We send speakers to a lot of these as well. And that's a great place for the folks that you're growing into your next Hadoop Ops leads to find a community and some people where they can share ideas and best practices with. So that's some feedback for this as well. I think we're at the end of the hour, so I want to thank you all for your, one of the last questions, will these slides be available and is this being recorded? So the answer is yes to both. So we will be providing the slides and we'll be providing the recorded webinar. So you can find both of these at cloudera.com. So thank you so much for your questions and your interest in this webinar. I hope you found it to be informative. And thanks so much for supporting Apache Hadoop, and thanks for supporting Cloudera.